Hello everyone, welcome to Catch 2 Mathematics. Catch 2 Mathematics is a simple game to practice elementary level addition and multiplication. Two random numbers are generated and the user must compute the answer before time runs out. The timer right now, for demonstration purposes, counts up to 8. When the time runs out, it will automatically enter the user's input and check whether it is right or wrong. The timer is reset whenever the user generates new numbers. There are two difficulty levels. Level 1 is addition and level 2 is multiplication. After 6 correct answers at a level, the difficulty will change. A total of 12 correct answers is a win. However, if the user accumulates 3 total incorrect answers, they lose and cannot submit any new answers. As shown in the schematic, the game starts at the input named activate, where it will generate 2 new numbers through linear feedback shift registers. Those numbers will go into the addition block and multiplication block, where their sum and product are computed. It then compares the user input to the answer. The multiplexer will decide which block to use. As it is the first round in the beginning of the game, addition is automatically sent. The block will send a signal of 0 or 1 depending on if the answers match. If the answers match, it will send a signal of 1 to D flip-flop all the way to the correct answer count block stage 1. Otherwise, it will send the signal to the incorrect count block. After 6 correct answers in the addition level, the stage 1 correct answer block will send a high signal to the multiplexer, in which it will switch to multiplication. If the timer ever runs out, it will automatically submit the user input. After 3 incorrect answers, a lose signal is sent to the D flip-flop, where it will make the D input 0 for any future submissions. In this schematic, we can see that after 3 incorrect answers, a lose signal will pop up, preventing the user from submitting any new answers in the future. In this simulation, we can see that after 12 correct answers, a win signal is popping up. After 6 correct answers, multiplication mode is turned on. In this simulation, we can see that after 7 correct answers, 2 incorrect answers, 1 correct answer, and 1 incorrect answer, it pops up with a lose signal because there are 3 incorrect answers in the middle of the game. In this simulation, we can see that the user has put nothing in the user inputs. After 8 clock cycles, the timer automatically submits 0 as their answer. It is shown here that 0 is the incorrect answer. Initially, we had 3 problems to solve in this design. How are we going to incorporate randomly generated numbers? How are we going to switch difficulty levels? And how can we put a time restriction on the user? In order to solve the randomly generated numbers, we had to look at a concept that was not covered in CPE 100, such as linear feedback shift registers. This is really cool as it mimics randomness but displays a constant list of the same numbers to make testing easier. Essentially, through the XNOR, the bits are shifted when it counts. For each flip-flop except for the second flip-flop, the D input is the previous flip-flop's Q output. The second flip-flop is the XNOR of previous Q output and any other Q output of our choosing. This allows us to have 2 LFSRs that produce 2 different sets of 2 different lists of numbers. In order to put a time restriction on the user, we used a basic 3-bit counter. However, we wanted the timer to submit the user's answer and stay paused until the user generates a new set of numbers. Thus, the counter includes a D flip-flop that would clear the T input of the signal clock once the max number 8 was met. Then everything would be reset by an activate signal that also generates the 2 numbers. In order to switch the difficulty level, we had to use a multiplexer and 2 3-bit counters. The first 3-bit counter would provide a solid signal 1 to the multiplexer once the requirement of passing 6 question level 1 was met. Then the second 3-bit counter would count how many correct answers were in level 2. Once the user gets 6 correct answers in level 2, they get a win signal. I think these aspects of time restriction, level change, and LFSR are the most interesting aspects of the design because they require either learning a new concept such as the LFSR or were challenging to implement. Although we couldn't implement the project on board, it was still a fun project that provides a great example of combining combinational logic and sequential logic into one circuit. Thank you.